So what are we going to do? Got more quiz problems to correct?
Yeah. Okay, the first one is find u dot v given that the angle between u and v is theta equals 55 degrees. Magnitude u equals 3 and magnitude v equals 2.
All right. They finally gave us a problem that I couldn't do by my method. So you need the equation for the angle between two vectors is equal to what?
That's something to do with cosine, right?
It's a complicated, yeah, it's the, well, let's write it from the start. The cosine of theta equals, you know what it is? It's actually not that hard to memorize. It's u dot v divided by the magnitude of u, the magnitude of v. It's actually very straightforward, which means theta is equal to the inverse cosine of that. And it looks to me like they've given us everything we need. So the inverse cosine, what's u dot v? That's what they want to know. So we'll just leave that as u dot v. And what they've really given us is theta. So instead of 55 degrees, that's what theta is?
Oh, yeah, 55 degrees.
Well, I gotta believe that that has to be in radians. Yeah, it is. So it's 55 times pi over 180 radians. So that's what theta is. And they give us the magnitude of u and the magnitude of v. So basically, we have 55 pi over 180 is equal to, actually it's the cosine of that, that's equal to u dot v over 6. So they're asking about u dot v. So multiply both sides by 6. That should be the answer. Now, let me just check here. The angle between u and v is the angle theta between 0 and pi, or between 0 and 180. So maybe I don't have to apply this conversion factor. Cosine of 55 degrees times 6 equals u dot v. Do you have answers on these at all?
No, I don't. Oh, it's multiple choice. if that's what you mean.
Okay. Let's get a number on that and see if it's in your multiple choice.
Okay.
Cosine of 55 times 6.
Uh, 3.44. Yeah, that one's on here.
Just for the sake of my curiosity, what's the cosine of 55 times pi over 180 times 6? But you would have to be in radian mode.
Okay.
And that answers my question, actually. If you switch to radian mode, you're going to get the same answer, 3.44.
Okay.
As long as your calculator is in degree mode, then this is the same answer as you would get if it was in radian mode and you put in that. Going to get the same number. We're going to multiply it by 6. So, the really key formula for the angle between two vectors is that. And I've spent 2 sessions with you teaching you a simpler method than this. But in other words, if you can figure out the angle that u makes with the x-axis and the angle that v makes with the x-axis, then the angle between them is just subtract those 2 angles. But this kind of question forces you to know the formula from the book.
Okay.
Okay? Because here's the formula from the book, and they're asking about u dot v. So you would have to do it this way. You couldn't do it the way that I was saying was easier. But this is fairly easy to memorize if you think about it. U dot v divided by the modulus of u times the modulus of v. All right, what else do you have?
Okay, so this one, alright, it's talking about the answer I got in the previous question. So it says use the answer in, yeah, I'll just give you the answer that I got for number 23 because I was right. So the answer for that was
3.44?
No, that was 18.
Oh, okay.
Yeah, I got some right here. So hold on, there's one more that I missed here. Okay, so ignore all that.
Okay.
Well, there's another one that I missed. Okay, which of the following polar coordinates match the rectangular coordinates 6 root 3 and -6? Oh, 6 root 3 is the x coordinate, and then -6 is the y coordinate.
Okay. So let's convert those to polar coordinates. So what are the equations that apply?
So y is...
The 3 main equations are what? What is x equal to?
X is the cosine of...
All right.
Just be the...
Let's figure out how you can figure it out.
Okay.
That's r. That's theta. This is x. This is y. What's the cosine of theta equal to?
So it'd be y over r.
Well, it's adjacent over
Or oh, right, x over r. Okay.
Okay, which makes x equal to r cosine of theta. Okay, so x is equal to r cosine of theta. What's y equal to?
R sine theta.
And what's r squared equal to?
That's... Wait, would that be a tangent, or would that be the Pythagorean theorem?
Pythagorean theorem.
Okay, so it'd be the square root of x squared plus y squared.
Well, r squared would be equal to x squared plus y squared.
Oh, okay.
Okay? And then the last thing you need to know is what is theta equal to?
Would be tangent theta, inverse tangent. Oh.
Think of what the tangent of theta is equal to.
Would it be inverse tangent y over x?
Yeah, but remember that that's only if x is greater than 0. What is it if x is less than 0?
You add pi?
Exactly. These two things right here are what makes the analysis of the angle between two vectors so much easier than the formulas they give in the book. If you can always figure out the angle between a vector and the x-axis, then it's really easy to figure out everything else, including the angle between two vectors and the projection of u onto v. All has to do with these angles that these vectors make with the x-axis. All right, so to convert this one, what is r going to be? That's the first thing. In other words, we know that these are xy coordinates. We want to turn it into r and theta.
Okay, so
we need r. What is r going to be?
That'd be the square root of x squared plus y squared.
Which in this case?
Square root of 6 root 3 squared. Plus negative 6 squared.
Okay, what's 6 root 3 squared?
Would I square them both separately and then add them together?
You'd square them both separately and multiply them together.
Oh, okay.
In other words, so the same thing as 6 squared times root 3 squared.
Okay, so that would be 36 times 3 then?
108.
Okay.
Plus...
plus 36.
That's 144. The square root of 144 is 12. So we have r. What's theta equal to?
Theta would be... so that would be inverse tangent of y over x. So inverse tangent of negative 6 over 6 root 3.
Plus pi or not?
Not.
Okay. So the 6's cancel, and we end up with negative 1 over root 3, which is the same thing as negative root 3 over 3. Which angle is that? You can use your calculator, I presume.
Yeah.
I mean, are you allowed to use your calculator to do these?
Yeah.
Okay. Although that is one of the special angles. That's a 30-60 angle.
Oh.
Okay. Let's draw the triangle. In other words, sometimes it's easier to use this model than it is. That's always 1. That's root 3. That's 2. So which angle is the tangent equal to 1 over root 3?
30 degrees?
Correct. Only it's negative, so it's what? It's negative 30 degrees.
Oh, is that it? Okay.
Which is the same thing as negative pi over 6. So you have r and you have theta. That's all you need for the polar coordinates.
Okay.
R is, I erased it. What was it? It was 12.
Would negative pi over 6 be the same as 11 pi over 6?
Yes.
Okay.
However, it's important to understand that when you use your calculator and you put inverse tangent of a negative angle, or of a negative number, excuse me, it's going to give you the negative angle. It's not going to give you 5 pi over 6. It's going to give you minus pi over 6. Okay. And that's somewhat important given the way that I've defined how you find theta. In other words, this is not a way that's in the book. This is a way that I've seen in another book. But if you define theta in this manner, then you have to use the negative angle, because sometimes the denominator is negative and you need to add pi to it. So if you got an angle of minus pi over 6 and you add pi to that, you get 5 pi over 6, which is the correct angle. So you must use the negative angle when you're taking inverse tangent of a negative number.
Okay.
We took the inverse tangent of a negative number. So the angle we get is going to be a negative angle. For inverse tangent, inverse sine, not inverse cosine, but tangent for sure, and tangent's the one you're always dealing with here. So whenever you have a negative number, you get a negative angle. Now, it depends on if your negative number is caused by the numerator being negative or the denominator being negative. If the denominator is the negative, you have to add pi to that answer.
Okay.
So the answer is 12 comma minus pi over 6. That is the polar coordinates for these rectangular coordinates. Really, the only two things we needed to convert polar to, or to convert rectangular to polar, were these two things right there. We didn't even need x equals r cosine of theta. That's usually what you need to convert polar to rectangular.
Okay. Next one is if Z1 equals root 2 CIS 28 degrees. Do you know what CIS is? Or is that kind of specific to this book?
I think that means this.
It's yeah, that's it.
Okay.
Is that what trig form is?
This is the polar form of a complex number, or the trig form of a complex number. They both mean the same thing. Okay. Polar and trig form of a complex number. The key is there's an I there. That's what makes it a complex number.
Okay, so if Z1 equals root 2 CIS 28 degrees and Z2 equals negative 3 CIS 144 degrees, then Z1, Z2 is approximately, and then there's the multiple choice.
De Morphs Theorem says that Z1 times Z2 is equal to R1 times R2 times cosine of theta 1 plus theta 2. Excuse me. I mean, this is stuff it's hard to memorize this stuff, but you can certainly look in a book and understand it. So there's De Morphs Theorem. Okay? And they've given us Z1 and Z2. Well, that's R1. That's R2. That's theta 1. That's theta 2. Okay?
Okay.
So it's just a question of plugging in. Z1 times Z2 is equal to square root of 2 times square root of 2, that's 2, times the cosine, what's theta 1 plus theta 2?
28 plus 144.
72 degrees.
Okay.
Plus I, sine of 172 degrees. Notice that there's no variables in that. In other words, that's going to give us a definitive answer. We can look up what the cosine of that is. We can look up what the sine of that is, multiply it, and distribute the 2. What do you get? What's the cosine of 172?
Negative 9.99.
The I carries forward, but what's the sign of 172? That's a positive number.
Sine 0.14.
Okay. So what we have is a complex number minus 1.98 plus 0.28i. That's A plus BI format. A is this, B is that.
None of those are the answers that were available here.
Read the problem again from the start.
If Z1 equals root 2 CIS 28 degrees, and Z2 equals negative 3 CIS 144 degrees.
I put Z2 is equal to root 3 CIS. You said, give me Z2 again?
Negative 3 CIS.
Okay, well that makes a huge difference.
Yeah.
Okay, so now R1 times R2 is what?
So that's going to be negative 3 root 2.
So instead of a 2 here, I should have a negative 3 root 2. And that's going to distribute to both of these terms. So what is negative 3 root 2 times negative 0.99?
It's 4.2.
What is negative 3 root 2 times 0.14?
Negative 0.59.
Is that an answer?
Yep.
Okay.
Thank you.
Yeah, on these Morphs Theorem problems, you just really have to, on page 526 of my book, they have the product and quotient of complex numbers. And if they're not going to give you these or let you have a cheat sheet, then you're just going to have to memorize.
Okay.
You know, is like Z1 times Z2, and that's times, not dot product. And Z1 divided by Z2 is the same thing, only it's R1 divided by R2, and it's cosine of theta minus instead of plus. Okay, so actually those hints are actually pretty helpful for memorizing this. But I will be honest with you, I have so few students who need tutoring on de Morphs Theorem that I don't have it memorized. I have my book open and I'm looking at it. So I would be kind of surprised if they really expect you to memorize those, but if they do, they do.
Yeah.
What else?
Okay, so here's the one where, so I'm going to give you the answer to the previous question. Now we can work with that. So, this is in component form, so it has the dashes, like the dashed, parentheses, you know, like the angled ones.
Not understanding you, but go ahead. Tell me what to write.
Well, you know how component form has those kind of like angled parentheses instead of the round ones? Like, it has like a...
Like those
Okay.
instead of print?
Yeah. Yeah, like that.
Okay.
So it's written like that. It's negative 188.9. and negative 404.8.
Okay, that means vector. When you have these signs, that means that's a vector, and I can draw that vector. It's in the third quadrant at minus 188, minus 144, which looks like something like that would look like. Okay, what's the question?
Find the ground speed and actual bearing of the plane.
Okay. The speed is the magnitude of that vector.
Oh wait, I got the speed right. I didn't get the bearing. That's the only part that I missed there.
This is the most important thing about vectors. Even though it's not even in my book, theta is the measurement of that angle right there. Theta is equal to what?
Inverse tangent x over, or y over x.
Only if x is greater than 0. If x is less than 0, what is theta equal to?
Inverse tangent y over x plus pi.
That is our case, right? So
yes.
Find the inverse tangent of minus 404.8 divided by minus 188.9. What's the inverse tangent of that in degrees?
Negative 4. Sorry.
That's all right.
So that is 64.98. Now we would add 180.
Yes, because the denominator is negative, regardless of what the numerator is. It does not matter what the numerator is. As long as x is negative, you add pi to it, or 180. And always make sure you look at, in other words, if you draw a rough diagram like I did, it doesn't even have to be exact. It just needs to be rough. But it tells you what quadrant it's going to be in. If x and y are both negative, it has to be the third quadrant. So I better have an angle that's between 180 and 270, and I do. 244.98. And that makes sense for that angle. You have multiple choice in degrees or radians on this problem?
This is free response here. So.
Oh, okay. Well, so you're free to answer in either one?
Yeah, but I'm looking at this and I just, the thing that I got wrong was I didn't add the 180. So.
Well,
yeah.
The only way you can, in other words, like I said, I have a pre-calc book that never even mentions this. But I have another pre-calc book that focuses on this. So it seems to be, to me, this is by far the easiest way to handle all of these vectors and polar equations. The angle is the key part. When you're converting from rectangular to polar or from polar to rectangular, this angle is everything. So these two equations, to me, I don't know how you can, to me it just makes this stuff so much easier. If you use these two equations as your direction angle. Remember the direction angle? All right, let me give you a little quiz here. I thought about this for a moment.
Well, first, is that in the bearing or is that the regular?
Well, no, that's the angle from the positive x-axis.
Okay.
So the bearing is from the north. So you're going to have to probably subtract 90 degrees from that. Bearing is measured from north, but it might even be measured clockwise instead of counter.
Yeah, it also goes clockwise, so.
Figure out what that angle is and figure out what this angle is. It looks like it must be 360 minus the one we came up with.
Okay. Is that it?
Yeah. In other words, the angle we came up with was this angle, measured counterclockwise. And that angle was 244.98. So subtract that from 360 and you get the bearing.
Wouldn't that give us the angle between the x-axis and... Like, it wouldn't go up to the y-axis, though, so we would have to add 90 degrees then? Because I got 115 degrees.
Yeah. No, you're right. Good catch. Yeah.
Okay.
Yeah, my 360 minus my angle would give you that, so you do have to add 90.
Okay. And what was that little quiz thing that you wanted to do?
Oh. What's the direction angle with that vector? If the coordinates on that vector are -1, 0.
That would be 180 degrees.
Yeah, as opposed to 0. And the reason it's 180 is because it's the inverse tangent of 0 divided by -1 plus pi, because this is negative. Well, the inverse tangent of 0 is 0, so I have to add pi to get the 180.
Okay.
But it's not the direction, it's not the angle between the vector and the x-axis. In other words, you could easily have answered 0 degrees there. It's the angle between the positive x-axis and the vector. Notice the difference. In trig, we were always interested in the reference angle, which was this angle here. It was just the angle between that line and the x-axis, but not in polar coordinates or vectors. In polar coordinates or vectors, it's the angle between the positive x-axis, this thing right here, and the vector.
Okay. Okay, so the next one, it's a work problem.
Okay.
There's a force of 30 pounds acting in the direction of vector 3, 4. Is moving an object square root 32 feet from 0, 0 to to a point in the first quadrant along the x-axis.
To what point?
Up to a point in the first quadrant along the x-axis.
And that's what we need to figure out?
It just says what work is done.
All right, let's draw a picture here. So if I go 3, 4, this is a good skill to have, to be able to approximate where something is. You don't have to chop it up into grids. You just need to put it approximately where it is. Okay? What should I label here? This is a force. Vectors are great at measuring forces or velocities. So this is 30 pounds.
Oh, okay.
Okay? And it's in that direction. And force equals, what formula have they given you for force?
I can't remember it.
It's something times distance. Force equals, no, work. This was a work problem, right?
Yeah.
Work equals force times distance. That's the physics.
Oh, okay.
And let's see. This is actually interesting and worth talking about, that work equals force times distance. What that means is that if you try to move a 100-pound object and you can't lift it and move it, it doesn't matter how much force you apply. If you do not move it, you do 0 work.
Okay.
If you lift the 100-pound object and move it 2 feet, then you do 200 foot-pounds of work. So work is always force times distance. Now, we know the force, that's 30 pounds. Presumably the distance, I think we can figure that out. I'm not quite sure from what you've given me, but we can figure out distance. So work is going to end up being a function of x. I'm thinking for a moment here. What was this that you gave me here? This was the work done?
Oh, that is, it moves an object. Oh, yeah, there's the distance. It's square root of 32 feet from 0, 0.
Okay, so the distance is square root of 32.
Yeah, would x equal square root of 32 then?
No, I'm trying to plug into this formula here. What is your question? What is the work done?
Yeah.
Okay, so the force is 30 pounds. So if I plug in 30 for force and square root of 32 for distance, is this, did you say square feet?
No, square root of 32.
32 feet.
Yeah.
Okay. Well, the work should be this. Now that does simplify. That square root of 32 is 16 times 2. So that's 4 root 2. So this simplifies to 120 root 2. The only thing is that we didn't utilize this 3, 4 in any of this problem, which I find puzzling. Is this multiple choice or free response?
It's free response.
Read the whole question to me again.
Okay. A force of 30 pounds acting in the direction of 3, 4 is moving an object square root of 32 feet from 0, 0 to a point in the first quadrant along the x-axis. Oh, so we would have to find the horizontal component.
Yeah, there, and now we're going to use this 3, 4.
Okay.
Well, what's the horizontal component?
Is that just 3?
The vertical component is 4. Well, it's not actually 3. It's, since the force is 30, this would be a 3, 4, 5 triangle, so I need to multiply each of these by 6.
Okay.
See why? In other words, this is an 18, 24, 30 triangle, which is a 3, 4, 5 triangle times 6.
Oh, okay.
Okay. So the work done, this force is not being 100% applied in the x direction. It's headed in this direction, but there is an x component of it. In other words, it's the equivalent of an 18-pound force along the x-axis.
Okay.
And 18 is what we want to put in for the force instead of 30. So it would be 18 root 32, which is 72 root 2. That is the force applied in the x direction, which has to be the case because we're moving it to x comma 0. So we're not moving it off the x-axis. We're moving it strictly on the x-axis. So basically you want, okay, if I have a 30-pound force moving in that direction, what would the equivalent force on the x-axis be? Well, it would be 18 pounds. In other words, if you had two tractors, one that could pull at 30 pounds in that direction and another that could pull at 18 pounds in that direction, they would be the same in terms of the force that could be applied on the x-axis.
Okay.
And that is the question. They want to move it from 0, 0 to x comma 0. So there's no vertical movement from the x-axis. Have you gotten into nth roots? Like what are the 8 roots of 1?
Yeah, we did that, but that didn't show up on this test, I don't think.
Not surprised. That is a difficult subject. I mean, if you go up to somebody and say, what are the 8 roots of 1? They're going to say, what? The only roots of 1 that I know are 1 and -1. But believe it or not, there are some complex roots of 1. In other words, you could find a complex number that if you multiply it by itself 4 times, you get 1. That would be the 4th roots of 1. And you have to use the Morphs Theorem for that. But let's not spend our time doing that if it didn't show up on the test.
Okay. Okay, next one. Okay, yeah, it's use the Morphs theorem to find the following. Find -1 plus I to the 10th. And write the answer in A plus BI form.
Okay. The Morphs theorem says z to the nth, and this is really where it has its best application, because that's not an easy thing to come up with, although I guess we could use the binomial expansion to come up with that. But de Morph's theorem is a little bit better. It says this. And I should have written it like this. Oops. This is quite helpful when you have a problem like this. So let's figure out what R is. Where it's the square root of a squared plus b squared. What's a squared?
So that'd be 1.
What's b squared?
I squared, but wouldn't that be
No,
-1?
it's the coefficient. In other words, when you're in a plus bi format, b is the coefficient of I. So it's just 1.
Oh.
Okay, so R is the square root of 2. Alright, so we've got z to the 10th power. Well, let's make this z is a complex number. So that to the 10th power is square root of 2 to the 10th power times the cosine of square root of 2 theta. What is theta again? And this is the same formula as with vectors.
Wait.
It's
what happened? Wouldn't we put n there?
inverse tangent of b over a instead of y over x.
Wouldn't we put n there, not r?
Sorry, what?
Behind the cosine, wouldn't that be n, not r? Like cosine n theta instead of cosine r theta?
Yeah, no, you're absolutely right. Let me erase that.
Okay.
We need to figure out what, yeah, it's 10. N is 10. But what is theta?
Inverse tangent of...
What's the coefficient? What's b?
Oh, so it would be I over -1 then? Or?
B is the coefficient of I.
Okay, so 1 over -1?
Since this is negative, plus pi. You with me?
Yeah.
What's the inverse tan of -1?
Not sure.
Tan
-40.
Yeah, tan of 1, you want to remember that. In other words, the tan of 45 degrees is 1. That's kind of worth memorizing, kind of like the sine of 30 degrees is 1/2. Okay? So inverse tan of -1 is minus 45 degrees, plus pi makes it 135 degrees. So that's theta. Okay? So I can plug in 135 degrees for theta right there. Plus I sine of 10 times 135 degrees. So what's square root of 2 to the 10th power? It's the same as 2 to the 5th, right?
Yeah.
32. Now, to do the rest of this, you're going to have to multiply 10 times 135, so you got the cosine of 1350 degrees. What does your calculator say that is?
You said 10 times 135?
Yeah, so what's the cosine of 1350 degrees?
0.
Okay. Plus, I'm guessing the sine of that's going to be 1. Sine of 1350? Could be -1, I guess.
Yeah, it's -1.
Okay, so that changes this plus sign to a minus sign. So there's our complex number that we're going to multiply by 32. So our answer is minus 32i. That's what that is.
Okay.
And that's the beauty of de Morphs theorem, is it allows you to do these kind of problems pretty straightforward without having to expand this thing 10 times. In other words, this would be a brutal problem to do manually.
Yeah.
All right, I actually have an 8:30 that I need to get to, Daniel, so
All right.
I'm going to have to leave you for now.
Okay.
You good to go?
Yeah. I'll book you again tomorrow for like half an hour.
Okay, for tomorrow?
Yeah. Yeah.
Okay.
Do like the same time?
Yeah, 7:30, that works.
Yeah.
Go ahead and mark you down here now. Just for a half hour?
Yeah.
All right, you got it. I'll talk to you at 7:30 tomorrow night.
Thank you.